One fire. One city. One factory making simple bolts. And somehow, Boeing panicked. Airbus panicked. Engine makers panicked. The most advanced jets in the world stopped being built. This is how one burning building nearly broke the entire aviation industry. It is 3 a.m. Philadelphia, Pennsylvania. February 2025. A factory is burning. Not a big famous factory. Not a place you have ever heard of. Just a medium-sized industrial building in a quiet part of the city. The kind of place most people drive past without ever noticing. The fire burns for days. By the time it is out, the building is gone. The equipment inside, gone. The production lines, gone. No one dies. The local news covers it for a day or two. And then the world moves on. Except, inside the headquarters of Boeing in Arlington, Virginia, nobody is sleeping. Inside the offices of Airbus in Toulouse, France, emergency calls are being made. Inside the engine factories of GE Aerospace and Safran, the companies that power some of the world's most advanced jets, engineers are staring at spreadsheets trying to figure out what just happened to their production schedules. Because that one fire, in one building, in one city that most people cannot even find on a map, just sent a shockwave through the entire global aviation industry. And the question every single one of those engineers is now asking is the same question I want you to think about right now. How does one factory fire nearly break all of aviation? The answer starts with something so small, so ordinary, so completely unglamorous, that when I tell you what this factory was making, you are going to laugh. And then you are going to realize it is not funny at all. The factory belonged to a company called SPS Technologies. And SPS Technologies was making fasteners. Nuts. Bolts. Screws. Precision hardware. That is it. That is the whole product. Little metal pieces that hold other metal pieces together. You can walk into any hardware store right now and buy something that looks almost identical. A bag of bolts. A few dollars. No big deal. Except, and this is where it gets interesting, the bolts that SPS Technologies made were not ordinary bolts. They were aerospace fasteners. And in the world of aviation, that word, aerospace, changes everything. An aerospace fastener is not just a bolt. It is a precisely engineered component manufactured to tolerances so tight that even a tiny variation can mean the difference between an aircraft that holds together and one that does not. Some of the bolts SPS made were titanium, a metal that is lighter than steel but stronger, perfect for the newest generation of carbon fiber aircraft. Specifically, the Airbus A350 and the Boeing 787 Dreamliner, the two most advanced passenger jets flying today. And every single one of those bolts, every one, has to come with a full paper trail. Documents proving it was made from the right material. Documents proving it was tested to the right standard. Documents proving it was inspected and approved by certified engineers. In aviation, the paperwork is part of the product. You cannot just go to a different hardware store and buy replacement bolts. The replacement bolts need to go through the same certification process. And that process does not happen overnight. So when the SPS factory burned down, Boeing and Airbus did not just lose a supplier. They lost a certified, approved, irreplaceable source of parts, with no quick way to replace it. And to understand why that is such a disaster, you first need to understand something that most people get completely wrong about how aircraft are actually built. Most people picture aircraft manufacturing like this. A giant factory. Raw aluminum comes in one end. Robots and workers build everything. A finished plane rolls out the other end. One company. One building. One process. That picture is almost completely wrong. What Boeing and Airbus do at their famous factories is called final assembly. Which sounds impressive, and it is, but what it actually means is that by the time a jet reaches their assembly line, most of it is already built. The fuselage, The main body tube arrives in finished sections made somewhere else. The wings arrive already engineered and complete. The landing gear arrives as a ready-to-install system. The cockpit electronics arrive pre-assembled. Even the cabin seats and overhead bins arrive as packaged modules. Boeing and Airbus are not really manufacturers. They are integrators. Their job is to take all these pieces, built by hundreds of other companies, in dozens of other countries, and bring them together into one machine. And the numbers behind that process are staggering. The Boeing 737, the most common passenger jet in the world, has around 700 suppliers. Each aircraft contains roughly 2 million separate parts. 2 million parts. From 700 companies. The Airbus A380 involved 1,500 companies across 30 countries, building around 4 million individual parts. All for one aircraft. Now here is the critical thing to understand. All of those parts, from the biggest fuselage section down to the smallest bolt, must be certified. Every supplier must prove, on paper, that every part they make meets exact aviation standards. And this is the system that the SPS fire just hit directly in the face. Because SPS was not a Tier 1 supplier making fuselage sections. They were not a Tier 2 supplier making actuators or sensors. They were a Tier 3 supplier. Sitting near the bottom of the pyramid. Making small parts. Parts that most people in the world would consider completely trivial. But remove those parts from the system, and the whole pyramid stops. Within hours of the fire, the phone calls started. Boeing called SPS. No answer, there was nothing left to answer from. Then Boeing called their procurement team. Then their engineers. Then their program managers. Then every alternative fastener supplier they could find. Airbus did the same. GE Aerospace did the same. Safran did the same. And very quickly, everyone arrived at the same conclusion. There was no quick fix. Here is the brutal reality of aerospace certification. If you want to make a replacement for an SPS fastener and supply it to Boeing or Airbus, you cannot just start making it. You have to first prove that your factory, your materials, your process, and your finished product all meet the same standards that SPS met. That certification process can take weeks. In some cases, months. And during that time, the assembly lines keep moving. Aircraft keep getting built. And those aircraft keep needing fasteners that now do not exist in certified form. So what happens to a plane that is 95% complete but missing its certified bolts? It sits. It just sits on the assembly line, or in a parking area, finished in every way that matters, except for the paperwork attached to a handful of small metal pieces. It cannot be delivered to the airline. It cannot carry passengers. It cannot earn a single dollar of revenue. Imagine building a brand new apartment, fully furnished, all utilities connected, everything perfect, except the building inspector cannot sign off because the door hinges are not from an approved supplier. The tenant is waiting. The rent is not coming in. And there is nothing you can do except wait for the right hinges. That is exactly what happened with some of the most expensive aircraft in the world. And the situation was worst for the newest, most advanced jets, the Boeing 787 and the Airbus A350. Because those aircraft used the most specialized titanium fasteners. The ones that SPS had perfected. The ones that nobody else was certified to make at the volumes needed. The fire did not just slow down production. In some cases, it stopped it completely. So now the real question. How does one Tier 3 bolt factory get this much power over the entire aviation industry? The answer is a word that sounds boring but is actually terrifying: consolidation. Over the past few decades, the aviation supply chain went through enormous consolidation. Smaller suppliers merged. Weaker ones went out of business. The survivors got bigger, more specialized, and more deeply embedded in the systems of their customers. And once a supplier proves they can consistently deliver certified parts at the right volume and quality, they become extremely difficult to replace. Because replacing them means finding another company that has the same certifications, the same tooling, the same expertise, and the same production capacity. And building all of that takes years. SPS Technologies had spent decades becoming the go-to source for high-strength aerospace fasteners. They had the certifications. They had the relationships. They had the knowledge built up over years of working with aviation engineers to produce exactly the right part for exactly the right application. They were, in the language of the industry, a single-source supplier for many of their parts. Meaning, they were the only certified company making that specific fastener, in that specific specification, for that specific aircraft program. Single source is extremely common in aviation. It is not a mistake or an oversight. It is often the result of the economics of certification. The cost of getting certified is so high that it often only makes sense for one or two companies to do it. And once they do, they own that part. Now imagine that supplier burns down. There is no backup. There is no warehouse full of pre-approved alternatives. There is just a queue of aircraft waiting to be finished, and a long, slow process of getting new suppliers certified to fill the gap. This is not unique to SPS. This vulnerability exists throughout the entire supply chain, at every tier. And the SPS fire just made it visible in a way that had never happened so dramatically before. Here is the thing. The SPS fire did not create a healthy system's first problem. It hit a system that was already under enormous stress. The COVID pandemic nearly destroyed aviation demand overnight. Factories shut down. Suppliers cut staff. Some went out of business entirely. Then when demand came back, faster than anyone expected, the supply chain was not ready. Parts were late. Materials were short. Deliveries slipped. By the time of the 2026 Singapore Air Show, one of the most important events in global aviation, executives were openly saying that persistent shortages were now the new normal. Lead times for titanium and nickel tubing, the raw materials used to make parts like the ones SPS was producing, had gone from around 20 weeks before the pandemic to 50 or 60 weeks by 2026. That is 3 times longer. For raw material. Before anyone has even started making a part. Then came the conflict in the Middle East. Boeing and Airbus sent urgent messages to their suppliers, asking them to identify any work being done in the region, and to assess how the war might affect their production. Airlines like Qatar Airways started parking jets because the conflict was disrupting their routes and reducing their need for aircraft. New aircraft deliveries that were supposed to happen, would they still happen? Would airlines accept new jets if their networks were disrupted? The SPS fire dropped right into the middle of all of this. Not onto a stable, resilient system, but onto a supply chain that was already stretched, already stressed, and already running with very little margin for error. One fire. One building. And the cracks that were already there became impossible to ignore. The SPS fire did not just cause a short-term shortage. It forced a conversation that the aviation industry had been avoiding for years. How dependent have we become on suppliers we cannot quickly replace? Boeing had already been learning this lesson the hard way. The 787 Dreamliner, their most ambitious aircraft, was built on a philosophy of maximum outsourcing. Boeing pushed design responsibility, manufacturing, and financial risk out to major suppliers around the world. The idea was that this would make development faster and cheaper. Instead, it became the most delayed, most over-budget commercial aircraft program in Boeing's history. Because when suppliers struggled, the problems all landed back on Boeing. When sections did not fit together properly, Boeing fixed it. When there were quality failures, Boeing's name was on the aircraft. The lesson Boeing learned, and the SPS fire confirmed, is this: you can outsource the work, but you cannot outsource the responsibility. That is why Boeing took the extraordinary step of reacquiring Spirit Aerosystems, the company that had been making their fuselages since 2005 as an independent supplier. 20 years of outsourcing. And then Boeing decided to bring it back in-house, because the risks of not controlling it had become too great. Airbus watched all of this closely. They had stayed slightly more vertically integrated than Boeing, not entirely by choice, but because in the 2010s they had tried to sell some of their manufacturing facilities and simply could not find buyers. That accidental decision left them in a better position. But Airbus also relied on SPS. Airbus also had aircraft waiting. Airbus also faced the same certification delays. The fire did not care which badge was on the aircraft. It hit everyone equally. And it made one thing absolutely clear. In a supply chain this interconnected, this specialized, and this globally spread, there is no such thing as a small supplier. There are only critical suppliers, and suppliers you have not yet discovered are critical. The next time you board a flight, I want you to do something. Look at the door frame as you walk through. Look at the rivets and bolts holding the structure together. Look at the hinges. Look at all those small metal pieces that nobody ever notices. Every single one of those parts was made by a company you have probably never heard of. Certified by engineers whose names you will never know. Documented in paperwork that runs to hundreds of pages. Tracked through a supply chain that spans dozens of countries. And when you sit down in your seat, every bolt in that airframe is there because it passed. Because someone, somewhere, proved it met the standard. That is not glamorous. But it is extraordinary. The Boeing or Airbus badge you see near the door does not mean that one company made everything inside that aircraft. It means that one company took responsibility for every piece, no matter who made it, no matter where it came from. That is a massive commitment. And it works. Every single day, millions of people fly safely on aircraft assembled from millions of parts made by thousands of companies. That is one of the great achievements of modern industry. But the SPS fire showed us the other side of that achievement. It showed us that when one link in that chain breaks, even a small one, even a bolt factory, the whole system feels it. And as the industry continues to deal with pandemic recovery, raw material shortages, conflicts affecting supply routes, and the pressure to deliver thousands of new aircraft to airlines waiting for them, the question of how resilient that supply chain really is has never been more important. One fire. One factory. One city. And for a period of weeks, some of the most advanced aircraft in the world could not be finished. Could not be delivered. Could not fly. Not because of a design flaw. Not because of a software failure. Not because of anything you would ever see on a news headline about aviation safety. Because of bolts. The aviation supply chain is one of the most complex systems human beings have ever built. It mostly works. It mostly delivers. And when it does, it gives us something remarkable, the ability to board a machine made of 2 million parts, built by 700 companies, and fly safely to the other side of the world. But the SPS fire is a reminder that complexity has a cost. And sometimes that cost shows up in the most unexpected places. There is a lot more to explore here: counterfeit aircraft parts, raw material fraud, the future of domestic versus global supply chains. We will get to all of it. But for now, I want to hear from you. After everything you just learned, do you think aviation is doing enough to protect itself from this kind of single-point failure? Or is the system too fragile for the world we are living in now? Tell me in the comments. I read every single one. I am Ben. You are watching Mentor Now. Stay curious, and I will see you next week.